So tonight we're going to be looking at programming. The 2023 beta software just came out, which we realized after last year that it should be easier to start teaching once we have the new software for each season, because they do make enough changes that it's kind of annoying to teach the 2022 stuff a lot to the beginners and then have to switch things up pretty quickly, because we normally wouldn't get started a couple weeks ago anyway. We'd have been started like mid to beginning of October at the earliest. So now's not too bad. Okay, so a couple things to get started. So we did Intro to Java a while ago. I'll probably push that back next year and make that a little bit later too, so it flows a little bit easier. But ideally, you should have some idea how Java works. Those recordings are up on YouTube. You can go through and get some idea what the variables and stuff are. And then most of it from there, that little bit of understanding, how we do math, how we do a couple things in Java, we can start looking at the actual robot code, and you can learn a lot about how the programming works from doing it directly on the actual software that we use for the robot, and through the simulator, and through the Romy robots that we also have. So one of the first things you have to do if you decide you want to, if deciding, partly being here and just deciding you want to start helping with code for the robot, is to set up the tools. If you have your own laptop or computer, it's definitely nice to have them on that device so that you can do it when you're not just in the lab. If you don't have a computer you can program on, we do have ones. We have the team computers that you can use while you're here. If for some reason you need to and you are really dedicated to it and you want to check one of those out, talk to me. We can probably work something out and have that happen. There's another presentation on installing the software. This is where it gets a little bit weird because the links are going to be different now for the beta. So I'll go through, just use the ones that we posted in Slack for the beta. But everything else you can follow along on this and get the WPI lib and VS Code software, and the installation guide takes you step by step through it. The installation guide will all be the same. Just instead of the installer saying 2022, here in the image it'll say 2023, because that's the one that we actually want installed. But all of this is still the same. So whether you're Windows or Mac, you can do, the installer for both exists. If you're Mac, let me know. I think I have to put the beta installer out there for you. But you can do it either way. And so that gets you fully set up to where you'll be able to have the VS Code instance, which is what we use to be able to write code for the robot. Let me get out of that. That doesn't make sense. Robot's probably easier. Okay. The default robot code and the templates that WPI lib provide do work, and that's kind of what we did with Photon last year with 8515. We were trying to run kind of a simpler code, and that sort of worked, but it wasn't advantageous for us in trying to move people up and have them make sense of how we do things on 3847. We structure things a little bit different in the code base for the 3847 robot for infrared, and it's changing even more going into this year, with the hope that by kind of sectioning things out a little bit, we can have more people working on the software for all of our robots. So we're going to use the same format for both Photon and for 3847, and for when we're doing Romies and when we're doing everything. So everything ideally is going to start looking a lot more the same all the time, because that wasn't how we were teaching it last year, and that didn't seem to work. So hopefully that'll be a little bit easier. So once you get VS Code installed, the second thing you should get installed is the GitHub desktop client. This lets us sync code back and forth from each other, and so we can all be working off of the same projects when we need to. And if we need to, if you're working on something and you want me to go through and check on it or something, you can send me a note, post it to GitHub, and I can pull it down and see what you're doing, and see if I can find the issue or make it work or go through something with you, whatever it is. In addition to that, we need to make sure you have a GitHub account. Make sure it's an education account. So I sent links a little while ago. I'll resend those. That lets you get some of the features, especially GitHub Copilot, which is super convenient. It definitely helps write code a lot faster. I'll show you what that looks like here in just a second. But once you have a GitHub account, We can get you added to the organization that we have, so then you can commit and upload files. We'll go through what some of the Discord, GitHub stuff looks like in just a second. Okay, so once we have everything installed, it is helpful to have a gamepad at home. It's not required. I end up doing it less than I used to. Now a lot of times I just use the keyboard emulation as a gamepad, and I can test things most of the time. But there are some times where it is useful to just be able to pull out a full gamepad and act like you're actually driving the robot or whatever, because we'll see in the simulator that it's pretty good. You can actually drive around, you can move things and test things and have the buttons do what you want. Okay, so falling back a little bit, back to some of the basics. Programming, most of the time, our goals for the programming software is so that we can have the robot under control, so it's doing what we want it to do. And ideally, on top of that, it's doing it in a way that makes it easier for us to score points. Most of you have driven or seen how the 2022 robots operate. You can imagine how incredibly hard it would be to score a ball if you were having to manually move a joystick to tell the launcher how fast to go. It would be incredibly difficult. Being able to hit a single button, having the robot figure out how far away it is from the goal, figure out how much motor power to give it to be able to keep it at a certain velocity, and figure out, and then another button just to feed the balls into the launcher, and they actually just go in, allows us as the humans to handle the rest of the complexity that's going on in the match, figuring out where to drive, figuring out where to go get the next ball, all of that stuff, and not worrying about minute implementations of internal robot stuff. So as much of that as we can possibly get the robot to do on its own, or make really simple where it's a single button press or anything, that's what we're trying to do. A lot of times we'll have some form of manual fallbacks, as in case some of those systems break, but most of the time we're trying to make it super easy so we can be faster at scoring points in whatever the game is, right? So if it's an elevator game, it's having different set points for each of those heights. Anything we can do to make it simpler on the drivers to score points faster, that's our goal. And anything more reliable, anything like that. And then in addition, autonomous mode is a big part of it, where we have that 10 to 20 seconds, depending on the game, normally about 15, to completely on its own without any human interaction. The robot needs to score points. This year it was trying to get as many balls as possible, eventually that 4 or 5 ball auto. So that's when we're doing all the path following, and having it do all of those things on its own, aiming, launching, everything. Some sort of elevator game or something, it might have to move up and down the elevator, score on different heights. All of that will have to be autonomous. Okay, so we're not following the rest of this anymore because it was running the basic 2020 EveryBot code as its sample, intentionally to try to make it, the goal was to try to make it kind of simple, but that left us too simple and we weren't able to do enough on top of it. So instead, we're going to be running the 2023 Romy code that we have written. And this is going to make a lot more sense and let us run a lot more stuff in the simulator. So until if you don't have GitHub set up, you're not entirely sure how to use it. If you do have this downloaded, you can actually just go here. You can click the code button and hit download zip, and it'll just download a zip file that you can unzip on your computer. And you can open that as a project, that folder. You can open folder in VS Code, go to wherever you unzipped it, so Romy 3847 2023, and then you can have this running without it being attached to GitHub. You don't have to worry about committing changes or anything. You can just be running this, and it'll run fine once you have the 2023 VS Code set up. Don't try to run this in 2022 VS Code if you already have that installed. It will not work. They don't work year to year. You have to have the correct year stuff installed every single time. It's kind of annoying. For any stuff that we do the beta on right now, for we have team laptops and stuff, we'll install it on some of them as we get to work on them. Once we do that, as soon as the season starts and we get the non-beta software, we'll have to install it on all of those. We'll have to install it again. So we end up installing the software a lot. So just kind of, if you're deciding you want to program more for the team, just get used to installing WPI Live. It happens regularly. Okay, so most of what I want to spend tonight on is starting to look at what's in the Romy software, and like kind of just our example training code. That's basically what this is. So it says Romy, but really it's a lot of stuff that happens in the simulator. And it's also just our first introduction to how the structure sort of works. So things to understand. So there is a main.java in pretty much everyone's Java code if you look at any of the robots, and it basically looks exactly like this, and you never touch it. So even though it's called main, we never go in here and edit it basically ever. If there's any time where you think you need to, you should definitely be talking to me or someone else and having a very good reason why we're editing main.java. All main.java does is it starts the robot. So it literally runs this method called start robot. That's the only thing it really does. And then robot takes over from there, robot.java. Let me go ahead and stop this so it's not distracting. Okay. So once you're able to have this up, we do have the ability to run this code in simulation now, which was a big push during the COVID lockdown. It kind of worked a little bit before then, but they really got things better in 2020 and 2021 to where you can simulate the vast majority of the robot fully in the simulator. Because the beta just came out, like literally it started working, we still got it, we got the installer like yesterday. There still are a few bugs, so some things don't work. Some of the things we need do work fine. So if we simulate robot code, so if you hit this little W up here, this is how you get into the full like WPI Lib suite of stuff. A lot of times simulate won't be the first thing, it's only there because I just used it. You can just type simulate and it'll show up. Or you can start typing simulate and it'll show up. And then once you click that, it'll go through and it'll do what's called build the code. So it takes all of this text and make it to something that the computer can actually understand. And then it loads the simulator. So this thing is called the simulator screen. It's also called Glass is the name of it. I don't entirely know why. But most of the time we just call this the simulator. And let me make it so you guys can see it a little bit better. All right, everything's bigger. Okay. So this has simulation of the full robot. So you kind of have all the basic stuff. So you can go in and disable Auton teleop. It tells you how long it's been running. It shows which joysticks are actually connected to the computer. So I have an Xbox controller plugged in because we were doing some Romy stuff earlier. And then we also have simulated keyboard joysticks. And so these let you, if you right click, you can do keyboard 0 settings. You can go in and you can change which axis is keyed to which keys on your joystick. So if I hit W, it moves axis 1 to -1. If I hit S, it moves it down to 1. Same with A and D are currently moving axis 4 in this code. And so you can just edit which ones you want them to, which keys you want to bind to any of the buttons or axes, and these just basically mimic there being an Xbox controller, but there's just not one. So that's really helpful if you don't have a controller with you. You can just use the keyboard, which I end up doing quite a lot. You can also do even more complicated stuff. So if you want to set like match times, you could. So if you want to like test run an auto or something, you can tell it that there's only 15 seconds left, so you can know that, and you can have it only run for that amount of time, that sort of thing. You can switch alliance colors or which station you're in. So if we wanted to simulate code like that, if we wanted to do things where we were checking what color ball we wanted to reject or whatever from last year, you can do all of that in the simulator. So a lot of basic stuff. And then you also have all of your hardware outputs and things too. So where it says PWM outputs, these are our basic motors. So for the Romy, PWM 0 and 1 are the drive motors. So when they're moving back and forth, we'll see these numbers change. And we can see that in the simulator when we actually put it into teleop mode and drive, which I'm going to do in just a second. And in addition to that, we can do even more stuff. So we have it set up in the code right now, and we'll go through some of how that works, where it's going to actually simulate the motion. So even though the Romy's not connected at all right now, as it moves, as it tells the Romy to move in simulation, it's getting enough feedback to simulated encoders to tell the simulator how far the motors have moved, and we can actually plot that out on this screen. So when I put it into teleop and I start driving around, so just with the keyboard again, I can do like WASD, and I can drive and turn, and you can see some approximation of what the Romy does. This is actually way too fast. Like the Romy is, compared to how big this field is, the Romy does not move that quickly. But you can adjust some of those things. I didn't want to leave it at actual Romy speeds because then it just like crawls and you see it down here in the corner. But there are some things we can do to make that adjustment. But for most of what we're doing, if we just need to test things, see how it works, you can do all that here. So if we wanted to change different drive modes, or have potentially, like, once we start doing more of the Auton pathing, you can actually have it drive paths, and you can see it do those paths on the simulator without having to actually do it on an actual robot. You can do all the simulator stuff, so you can do it in your room if you don't have the Romy at home. You can do all of that however you want, and then you can come here, test it on the Romy, see if it works there, and then a lot of those same principles will apply to doing it on the full-size robots. Because again, all of this code is exactly the same stuff that we're doing. It's not going to have the same values, because moving the simulated robot here or the Romy are definitely going to be different settings and tunings and stuff compared to the big robots. But all of the basics are all going to be pretty much the exact same. The other things we have are any of the other hardware outputs and stuff. So if we wanted to actually see the encoders, we can do that. So it'll pop up a little window, and we could like see as we move, it shows the counts changing. So these encoders are what count how many times the wheel revolves, or how many times the motor revolves. So as we move it, it goes up. As we move it backwards, it goes down. And so this is giving an idea of the position of the robot on the field. And it does a pretty good job of figuring that out as we're driving around and testing it, whatever we need to do. It also has all of the things that go over to our dashboard. So you can actually, with the simulator, we can start tool. So if we want to start shuffleboard, which is the dashboard that we use to view different things, set the different autonomous modes, all of that, we can launch shuffleboard, and it'll connect to the simulator. So you actually see a little log message right there saying shuffleboard connected. And so we can see some different values on here. Certain things aren't running that had been, so it's not doing everything. Let me make a new one so it only shows up what's actually there. Okay, so it's only showing certain things because there's a couple telemetry issues going on with the beta, so I had to turn some stuff off. So it's not outputting very much stuff right now. But if we are, let me see if I pull, the screens get a little small. If I end up in the simulator and I start moving around, we can see the robot move around on this screen as well in the shuffleboard. So that's useful. We can also get any of the same feedback if we set up anything that we were doing on the real shuffleboard dashboard when we go and then change different values, or if we need to see what an output is, we can have all of that present here in the simulator the same way. If we're doing like Auton switching, when we have to like tell it which Auton path to select, that can all be done the same way, so we can make sure all that code works. So there's a lot of things that we can test and see that it works before we ever have to turn on the robot and do it all that way. Because once we actually do it on the real robot hardware, several of you were around when we were doing that for the Autons and stuff. It takes a while because you have to physically move the real robot back into place every time. You have to swap batteries all the time. You have to be worried that the robot's just gonna like run into you if you mess up. There's a lot of things that you have to be a little bit more worried about when you're doing it on the 140-pound robot versus when you're just doing it in simulation. And you can try and test and figure out all the different stuff you want on the simulator or with the Romy that also doesn't hurt you if it runs into you, well before we get to the bigger robots. Some other things that you may have noticed that we haven't talked about yet. So this does have the setup for addressable LEDs in here. So as we're doing things, I think it's set up and disabled right now. So if I so if I hit different buttons while in disabled, I can tell it to go to solid. I can tell it to do different like flashing patterns, I'm pretty sure. I can go to rainbow. There's some other things it can do. So I think it's different if you, I don't remember exactly what everything is set as. But yeah, there's different things you can definitely set it to do. And so this is similar to how we were planning to run addressabilities on our actual robots if we want. So we have a whole setup for that in the code. And so you can learn how to have it all set up. You can program different animations on it, which is one of the nicer things you can do in simulation without worrying, and one of the things that can definitely be used on a robot pretty quickly if we had a cool LED animation we wanted to do. That's a good way to learn how some of the commands work. So there's a lot of things you can do directly in the simulator without having to have a Romy or the full robot. Okay, so looking back at the actual code and how some of this is actually working, the main idea of this next year's organization system is that ideally most things that are happening on the robot are going to be separated out into their own folder. So our current organization plan for the 3847 programming side is similar to how we had mechanism leaders on mechanical, like CAD design, where somebody's in charge of designing the launcher, or someone's in charge of designing or in charge of managing the design process of the launcher. They're not solely responsible for doing it, but they're overseeing it, making sure the manufacturing process happens, the CAD process, all of that happens. Similarly, we're planning to do that with software this year, so we can split it up a little bit easier, and ideally try to get more people involved. So there should be, I think the 5 right now, my guess is that we'll have somebody responsible for autonomous, so that's mostly the path planning and actually making sure all of our auton routines work well. Someone specifically responsible for swerve, because there's quite a bit of tuning and programming that goes into just making sure the drivetrain is working well, and that kind of feeds into the autonomous working well and like every other subsystem working well. If the drive isn't working, nothing else does. They'll probably also be somewhat responsible for like the pilot's controller, making sure the control scheme and stuff makes sense. And then there'll be another leader responsible for most of the game piece manipulation and scoring. So this year it would have been the commands and subsystems for intake, ball path, and launcher. And then also that'll be also responsible for like the pilot or the operator controls, so like the button mapping and any tuning that goes into the controls for the operator. There'll also be someone responsible for vision, which we haven't really talked about here because that's a little bit trickier to simulate, but you can a little bit. There are ways to have like photon vision running and communicating to the simulator, so that you can be checking, like if you want to start playing with April tag stuff, you can be running it on a computer, making sure the different settings are coming back correctly. You can do a lot of things in the simulator a little bit. You can do some of that on the Romy as well, so we can have photon vision running on the Romy and checking for targets and all of the things that we end up doing with vision. So if any of the vision tracking is something you're interested in, there's going to be probably a decent or a pretty good amount of work this year into vision, because now we have both the reflective tape that we had been using for the last long time, like 2012, 2011, technically 11, really 12. And then now we have April tags, which are kind of like very, very low resolution QR codes that should let us do some localization stuff too that we just started playing with, that we'll have more information about a little bit later. And then also endgame, where we'll have somebody responsible for making sure we can program all the climb sequences or whatever the endgame is. We don't know if it's climbing, we don't know what it is. But whatever the endgame is, there's normally enough stuff that happens there that's pretty separate from the other 4 things I just mentioned. So ideally, a lot of those are going to be their own folder, and some of them will have multiple folders. So in this case, Auton would have a single folder where they're going to have the commands that go into it, which are individual things that are run when we, for like each of our Auton commands, you get one. So if we have a 5-ball path or something, if we have the 2-ball, like all of those get their own file, which is called a class in Java. And they get their own, well, sort of, but they get their own file for each one. I think we can run Auton actually. Let me double check that that works. I'm pretty sure it does. I haven't tested this on the new stuff, but I'm pretty sure if we tell it to run auto, oh, maybe not. Okay, well, I need to switch something. Something broke in 2023. It used to work in 2022, but there's a couple different changes that I haven't fixed everything yet. Like I said, we just got this yesterday. But I'm going to try to get this all fully tweaked this weekend and early next week, so then November 12th and 13th, we can go through and have it actually running on the roamies and everything. If people want to start playing with it now, we can. There's just going to be more bugs over the next week while we're still tweaking a few things. But we can do things like some basic auton distance things where we're just telling it to drive a certain distance at certain speeds, which are pretty simple commands like that, up to when we start doing some slightly more complicated. This was the beginning of some of the 5-ball stuff where I was just playing with the things. Our actual, we can go back and look at some of the actual 2022 things once we start getting more in depth. But for a lot of the simple ones, this is kind of what it starts looking like for some of those things. Again, this is not time to learn and expect you to know any of this. I don't. As you decide you want to start getting more in depth on any one piece, then I can start walking people through things. We'll have some different times to go over some specific things with some specific general things that everyone kind of needs to know. But if you want to be like in the Auton group, then you'll know all of the things about how Path Planner works and all those nitty-gritty details. But if you're just doing endgame, it doesn't make sense for everyone to know those same things. Similarly, there'll be some things that work for everybody, or if somebody wants to help but not be responsible for some of the more scoring stuff, things like the LEDs, where we can set up different animations and have those work, and one of the other groups who's doing things can call those, and they can provide feedback to the drivers. There's a lot of different things we can do with them, and now we have it set up to where the scheduler works, where like when you can hit a button, it knows how long to run it for. You can have priorities, all sorts of different stuff to how the LEDs can work and all the different types of animations. So you can do blink and rainbow and snowfall, and we can write animations all we want that kind of tell it how to do different things. So this is a lot of kind of, if you've done a computer science class, this is going to be similar to that, where you're just doing for loops and you're figuring out which pixel to set to which color and when, and that sort of thing. What else are we looking at? So yeah, so back to the important part of this is that ideally everything's going to be set to where most of the time you're only going to be working in folders that your group of people are going to be the only ones really messing with. So you can't do, it should be a little bit easier to entry because you can't really mess anything up over the entire robot, where last year it was really easy when there were certain things that you had to do in like the main robot file, where if you just like deleted a line, the whole robot may not work, and that can be very scary and intimidating, and I understand that. I don't like that either. Where now you should be able to do most of your stuff just in your own folder. There'll be a couple of us who do all this stuff on the main robot and just make sure everything's set up correctly. But largely you can be working in the folders and not interfere with any of the other stuff all that much. Similarly, in GitHub, we'll be able to have different branches, so you can be working kind of in your own code, commit things all you want and make changes, and then only when you're happy with it and things are running do you actually publish it and everyone else starts using your code as well. So you have a lot of leeway to be able to test things, make mistakes, learn as much as you want without affecting everybody else doing the same thing. Because everyone else can make their own mistakes kind of in their own areas and can fix them at their own time, which is a lot easier than kind of where we were last year, where that just wasn't really possible. Okay. How much time do we have left? A little bit. We can do that. Okay, so let's look at, I need to make a simpler version of this at some point. This is simple enough. Okay, so let's kind of look at what drivetrain looks like at a pretty basic level and kind of what a subsystem is and what commands are. So we have some idea of how those work, because those are kind of the building block of everything else we do with robot programming. So a subsystem, and we kind of know it's a subsystem because it says extends subsystem base here. And that's one giveaway. There are a few things that'll extend something else that also extends subsystem based, so we won't say that, but it does the same type of thing. And subsystems are places where we define how we interact with actual hardware on the robot most of the time. So in this case, this is everything that deals with the drivetrain for the Romy, driving it around and in the simulator. We define it here so the robot knows kind of what we're talking about and how to talk to it. So in this case, the drivetrain obviously has two motors, so it has a left motor and a right motor, and we name them here. We create them, so in this case, they're called Sparks. Spark is just a name for the Rev speed controller, the kind of really basic one, and that's what they use to control to imitate what the Romys are doing. So you tell it like how to contact it. So we have a config file that tells us which port the motor's plugged into. So a lot of times in VS Code, you can just right-click and go to definition, and it'll tell you like what this thing is. So in this case, drive motor left equals 0, and drive motor right equals 1. So this gives us a list of all the motors that we're planning to use in this case. So we have the same thing on the real robot where we make sure we're not, assigning motors to two of the same places, so the robot tries to like talk to both the intake and the climber at motor 20 or something. That wouldn't work well. So you have to make sure you're giving them all their own unique numbers. The config file, we set the numbers, but we give them all their unique names, so it's easier to reference everywhere else in code. Okay, from there, we do a couple other things just to make things easier. So WPI, the library already creates a thing that lets differential drives work. So where we have the motor on each side and we're able to drive it forward and backwards and stuff in turn, they have a class that makes that a lot easier to do, so we're not directly controlling the motors. So we create one of those and tell it where the left and right motor are. There's a few other things that we'll look at later, but we're going to start kind of trying to subdivide things a little bit easier so we can have this kind of basic drivetrain, but then we can make it more advanced by having odometry, which is using the encoders to track our position. Any of the simulator stuff gets put in its own file. And then some advanced stuff when we start doing some of the path planning and any of that also gets put in its own file. So we can kind of build up to more and more advanced stuff as we go. And most of it just involves putting a line like this, telling it that it exists, and then making a new one right here, which is pretty much, you can just do that pattern matching, and we can eventually go and look in those other files and see how those work and how they exist. But for the drivetrain right now, all we need to worry about are like these three things are the things we're playing with right now. And that lets us do what we want to move the robot around if we're actually connected to a Romy. So once you have that, we also did set up the config. So drivetrain config gets it's its own file too, so each kind of subsystem has a config class in our setup. This lets us have all the different places for our settings, things we're going to tune. So in this case, some of this is like Romy stuff, so it's literally like the wheel diameter of the Romy, which is really tiny in meters, because it's normally for the robot. Same with like track width, so how far apart the Romy's wheels are. And these are a lot of the same things we tune for our competition robot. And then this new one will also let us change some things based on whether it knows that we're running on like the comp bot or practice bot, or if we're running in simulation. We'll be able to change some of those tuning settings so that it'll work a little bit easier. That was one of the things we had a problem with last year when we were changing things between the practice bot that became 8515 and the comp bot. Some of the times the settings need to be a little bit different, and we didn't have a really great way to do that. This setup works a little bit easier. We can set some of those constants directly in here, and then once the robot loads, it figures out which robot it's on, and it's able to change all those settings for us. Okay, so the other things that happen in the subsystem is you provide basic methods telling it how to interact with that subsystem, how to do things. So in this case, we have an arcade drive, which is a really simple method that just takes the speed that we want to go and the rotate. I'm not sure why it's called x-axis speed. That's weird. Yeah, I'm not sure why. Oh, it used to be. It should just be axis for speed. It doesn't matter what the name is. But this is just taking speed and rotation. So you can put in the values that you want it to drive, and it'll do that. So if you put in 1, 0, it would go full speed forward. If you put in 0, 1, it would turn full speed while not going forward or backwards. But then if you put in methods here that we're actually getting joystick values back, this is how we're able to control the robot. And we'll look at that in just a second when we get to commands. And then we also have a method to stop the robot, which is very helpful. So we can just tell it, don't move. You could also call this with 0, 0 in it. But specifically calling stop motor is helpful. Okay, so once you have kind of your basic method set up in a subsystem, then you need to have commands that act on those methods. So one of them, drivetrain commands. So yeah, so we have another class called drivetrain commands, which for most of your pretty basic commands, when you don't need them to do a lot, we're going to be able to put multiple commands into this one class that we're able to call later. So one of those commands is the default command. So we have the setup default command method. And it's created a very basic command that all it does is call robot.drivetrain.arcade drive. So that same one we were looking at. And then it passes the pilot's gamepad's get throttle joystick to it and the pilot gamepad.get steering joystick. So then we can go in here in our pilot gamepad and configure what the throttle and steering axes actually are. So if we wanted to change from the left stick being forward and backwards and the right stick being left and right, and we wanted to make it like the left stick was forward and backwards, but the triggers were left and right, we could just change what's sent back here and get driver steering or get drive steering. And we can do that right here. So that all happens in Pilot Gamepad. So if we're trying to remap anything, if we want to change how a button is, all of the buttons for what happens in the gamepad are all done right here. So we can reconfigure any of those things for the two drivers without having to do them in the drivetrain itself or anywhere else. That should be, or that's the goal at least. So by this being the default command, that means if nothing else is trying to use the drivetrain, if we're not telling the drivetrain to do anything else, it's always just going to default to that command. And that's almost always what we want it to do for the drivetrain, is we want it to basically always let the driver drive it whenever that's possible. That doesn't mean that it'll drive like during disabled. That all happens separately to disable the motors then, and for this command not to work anyway when it's disabled. But any other time, it's just going to be asking for this. Same with Auton, it's not able to get the pilot gamepad stuff, so it's always returned 0 during Auton. So it's fine if we're not doing anything else in Auton, it would still just be 0 there. And then we also have a command for stop that we wrote. So if we need to stop the robot for some reason, that works there. When you do have more complicated commands, some of these were default ones that I left in. But you could have things like drive distance, and these have the full, what we kind of call the full command layout. And there's sometimes where you need all of this. I don't want to go too in depth right now, but this lets you do things like run once when the command starts, run the entire command, run every time the command's running over and over again. This is where you actually like set the speed to tell it to keep telling it to go whatever it is for how long it's going to go. And then at the end, we can tell it to stop. So here it's 0, 0. It's not using stop, but we could easily change this to use stop. So instead of .arcade drive, we could tell it to stop, and that does the same thing. Like I said, this was written not by me. This was one of the default ones for the Romy. But that's a good way that we can improve it a little bit, because this is a lot easier to read than what was there before. And so part of what we're always trying to do is make things a little bit simpler, a little bit easier to read, and just so it's easier for us to know what's going on as we're looking through it. And if we ever have to find something weird, or if the robot's not doing what we want to be able to very quickly diagnose where that is, where do we need to make the right change to make the robot do what we want. Okay, so with those commands, we're able to then manipulate the robot in whatever ways we need to do. So this one doesn't have too many in like drivetrain commands. Some of the others get a little bit more. So elevator command doesn't have a ton. We'll look at the elevator sim a little bit later. I think it's broken right now. I need to fix to actually show it. But this will eventually let us have an elevator that kind of moves up and down here. I don't think it works. Let me double check. Yeah, it does not work. It says it does, but it doesn't. Okay. So that's one of the bugs for this year. Something slightly changed in 2023 that I need to go in and change. This should let us have it to where you can tell it to go to a certain height, and it'll be able to actually like show it going to that height, and then coming back down when you let go, and then we can look through how to actually configure it and tune all the settings to make sure that it's actually going to that height, because there's a little bit more work than just telling it to go to that height. You have to tell it how it's going to get there. And so that's one of the bigger parts of a lot of robot programming. The same way that we tell like the launcher motor to go to a speed, we have to tune a lot of little settings so that it knows actually how it's going to get there, and how it even knows that it's finished. All of those things have to happen. So that's a lot of what this ends up being, are tuning a lot of settings in the config files to let it know how to do some of those things. Cool. Okay. What else do we have for tonight? I think that's most of what we had for tonight. Some stuff from last year. Okay, so yeah, I think that's most of where we're at now. So moving forward, so what are we doing? So the two main things is, if you have your personal device that you want to be able to program on, make sure you download the WPI Lib software from the Google Drive and install that, the 2023 beta. Make sure you install GitHub Desktop Client and create a GitHub username with the education link that I'll find and send out again. Oh, I didn't show what GitHub Copilot looks like. So GitHub Copilot is pretty cool. So we're in, let's see, so if we go into drivetrain, let's say we hadn't written the stop method yet and we're just going to rewrite it. So I'm going to delete it. Let me see. Oh, GitHub Copilot is running? Maybe? I don't actually know if it's running. Let me see if it's running. Yep, it's running. Okay. So it's suggesting something for me to complete here. And it literally just will pretty regularly, if you're just at a blank line, it'll suggest in gray what it thinks you want to write here. So it's actually thinking I want to write this comment. I don't. So this would be like if I was writing a tank drive method. So it literally thinks I'm going to write a tank drive method next, because I just wrote arcade drive. So it's like predicting pretty well, based on a lot of other people's code and a bunch of other things, what it thinks you want. I don't want to write that comment right now, or I can start writing a different comment. So I can write like stop. So I'm going to say stop the drivetrain, and I can just hit tab and it'll do it for me. When I hit enter, it'll predict what code I want to actually have that work. It didn't quite get it right. It got it close. So this would actually work, right? This would completely work if you wrote this. There's no problem. We already talked about arcade drive 00 being another way to say stop. So it predicted that, and it's fine. You can also do stop here, which also works. So again, it's not going to be perfect, but it does a pretty good job of kind of guessing what you want. And if you're not sure exactly how to do something, looking at its guess and figuring out if its guess is close is pretty helpful. There's a lot of times where we have to write some pretty repetitive code sometimes, where it's a lot of like the same thing, but with like slightly different words or names or something. We try to avoid that, but every once in a while it still has to happen. Copilot makes that way simpler because it'll a lot of times just do that for you, or pretty big chunks of it. So I highly recommend playing or getting Copilot set up and being able to have it installed on your VS Code. You do have to install it. It's an extension. So over here in extensions, you have to search for Copilot and hit install. I already have it installed. And then it'll make you log in with your GitHub username and password. What else needs to happen? I need to figure out. I don't have it currently set up on our Spectrum 3.7 like team account, so that's one of the things I know on my task list is to try to figure out how to get that to happen. So like it has an education account somehow, so that we can get free Copilot. I don't know if we're going to be able to do that. If we can't, we might just be using like my GitHub account or something on a lot of these. I'm not really sure what the aperture is, but we need to have it on the team laptop somehow. I haven't figured out the best way to do that. I don't want to have everybody try to like log in every time they start using the team laptop. That would be pretty annoying for some of the things. Okay. Were there any questions about what we kind of talked about today? Again, the main thing is just getting the software installed. And then if you want to start playing with the 2023 stuff and looking through kind of how things are organized, that's a good place to start. Outside of that, I think our next step, we're going to probably have some more of these sessions where we dig into a very specific thing. So kind of like what we did with drivetrain, except expanded to where we get into how the actual odometry works, how some of the pathing works. We'll actually, hopefully we'll get the elevator sim stuff working again, and we'll be able to do how the elevator simulator works and how our PID and commands and things work for all of that. Currently, the Falcon simulation doesn't work right now, so it doesn't actually show the Falcon motors. So that's what intake example is, but we can't see that until they update the latest Falcon stuff, which should be at some point in the next couple weeks. But we can still do a lot in here without that. And then the roadmap ideally is to get some of this work through and play in the simulator. And then if people want to move to the Romy, we can. And then we'll eventually work on getting the 4 swerve robots that we have available driving on the new software is kind of the goal. So we have Flash, which is the name of the original swerve like test bed, the 2021 robot, and then both 2022 robots. Ideally should all move up to 2023 code that gets all reorganized and everything. So it's a decent amount of stuff to do between now and hopefully January. But some of this can push in. So if we're still doing this around kickoff and we're working on that, that's fine. Like anything we're doing now is all going to benefit our 2023 software anyway. So some of that's going to be playing with those robots and getting them ready for being able to test and work through stuff in 2023. Similarly, if you're really excited about, or if you're really interested in doing any of the vision stuff, let me know. There's quite a bit of stuff we can be moving in that direction. That's a little bit different than what we'll probably be doing with everybody, because a lot of that work gets done not directly in robot software. It gets done on the Limelight software and Photon Vision and some other things like that. Some of it comes back into here, but we kind of have to play with the actual camera stuff and how we track things, which are on different computers or that are on the robot separately. Okay. Any other questions or anything I can answer tonight before we log off? All right, great. I will stick around for a little bit if anybody wants to ask questions afterwards. But otherwise, thank you.